Everyone, welcome to Theory of Computation class. This is Karunamurthy from Erode Chengandar Engineering College. In this session, today we will see DFA problems, right? So how to solve the deterministic finite automata problem and also what is the procedure to construct in the DFA. So in this session, we will cover this one. So after completing the construction of DFA, that is rules and regulations, then we will see some problems. So in last video lecture itself, I told about NFA, DFA and all. So let us quickly recap what do you mean by DFA and all. The expansion of DFA is nothing but deterministic finite automata. So deterministic means the uniqueness of the computations, right? So this finite automata are called deterministic finite automata if the machine is reading input string one symbol at a time. In DFA, there is only one path for specific input from current state to the next state. So in DFA, only one path, it will be read only one input symbol at a time. It is only one state. So that is very, very important in DFA. So, and also deterministic finite automata does not accept the null move. This null move is nothing but epsilon move and all, right? So that is that DFA, deterministic finite automata, cannot change state without any input character. So whenever we want to pass one state to the another state, you must pass any one of the input symbol. That is very much essential. So in NFA, why I stress over here in the sense, in NFA, they may read the input symbol epsilon, but here epsilon symbols doesn't takes place in my deterministic finite automata. So DFA can contain multiple final state. It is not conditioned to provide only one final state. It may be more than one final states should be appear on your DFA. So it is very much useful in our lexical analysis in compiler. So this is formal definition of DFA. So normally in DFA, 5 tuples available. The first one is capital Q. This is nothing but finite set of states. Next one, the summation symbols. This summation symbol here we are going to be call it as a alphabet. So it represents finite set of input symbol. Q naught is initial state, F is final state or accepting state. Here not only for the single final state, it can be a more than one final state. Okay. So finally, this del symbol here represent for transition function. This transition function can be defined as, see here, this is the main difference. In your finite set of states contains some input symbol, it will be reaches only one state. Okay, that is my DFA. So this is the steps to construct the DFA. So in theory of computation, definitely we want to draw the machine for DFA. Okay, so many questions are arising in the constructing the DFA. So before going to be constructing any kind of problem, any kind of situation, you must follow some steps. Okay, the first step, we want to determine minimum number of states required in the DFA. So normally, whatever may be the DFA problem, definitely they may give some hidden information, like a substring, like that, like that they may providing some substring. First of all, you must identify the particular substring, right? So first we want to calculate the determine the minimum number of states required in the DFA. Then you have to draw those states. So how to determine the minimum number of states? That is, we want to follow some rule. First, we want to calculate the length of the substring. So in the question itself, they may given some information. So that information is nothing but your substring. You must calculate the length of the particular substring. Along with that, you please add one more one for your required minimum states in your DFA. That's the thing here I given. All strings ending with n length substring will always require minimum n plus 1 states in the DFA. Let me see the example. I think you people all understand better. So the first step. The second step, we want to decide what are the strings can generate for the DFA. So you can write out the particular string, then the particular string want to accept it for the DFA. So this is the second step. The third step, we want to construct the DFA for the strings decided in step 2. What are the strings you are decided in the particular DFA, that one you have to apply in your automata. Okay, so remember the rule. We cannot able to provide separate diagram for each and every string. So the entire string, what are the strings generated for the particular automata, you have to consider only single mission, not for more than once, not more than single mission. Okay, so while construct DFA, always prefer to use the existing path, and we want to create a new path only when there exists no path to go with. So this is the rule you have to keep in mind. So according to this step, we want to see problem now. Okay, so this is problem number 1. Now I want to draw the DFA for the language accepting the strings ending with 0, 1 over an alphabet 0, comma 1. So what is the meaning of the particular problem? You please try to understand that one. So here what they may asking, you can generate whatever may be the string combination of zeros and ones, but end with what? 0, 1. Okay, so let us draw the diagram here. See, here the ending string is 0, 1. So this is the substring, right? So what is the first step? All strings of the language ends with substring 0, 1. So what is the length of the string? 2. That is here I represented. Okay. So along with this 2, you have to add 1. So totally you need 3 states to construct this first problem. Okay, it suggests that when you use DFA, we'll have 3 states. Why? Because my substring length is 2, and according to that, you have to add one more. So totally 3. So this much of states are required to constructing the DFA. So the first thing, what? 0, 1. Okay. So next one. So these are all the possible strings. So these are the possible strings I want to accept it in my required DFA. So not only the 3 strings, you can send it whatever may be the string. So what is the condition? See, ending with 0, 1, right? So you can this is my ending with 0, 1. You can make combination of zeros and ones here, like 1, 0, 0, 0, 1. This is also possible. Why? Because the end of the string is 0, 1. And also you can make 0, 1, 0, 0, 0, 0, 1, 1. So this is also right one. Why? Because my end of the string is 0, 1. So before that you can make more number of zeros and more number of ones. Okay. So according to this condition, I want to draw the DFA now. So this is the DFA. Okay. So here, listen, the first thing is 0, 1. So for that, how to draw the diagram? See, first, actually, we can draw like this. What is the first thing? 0, 1, right? So how many states I need? 3 states. Q naught, which one is accepting state and which one is start state. Here I mentioned Q naught is my start state. The free incoming edge that is called initial state. This informations everything I provided in the previous lecture video. So this is my final state. So whenever you represent the final state, you just make it as a double circle. Okay, what is the first string? 0, 1. So this particular string 0, 1 is accepted for this automata. Then what is the next string? See, 0, 0, 1. So 0, 0, 1 in the sense where I want to put, I mean, the next string is 0, 0, 1, where I want to put the 0. In case if you have put 0 over here, once if you have put 0 in the Q naught state itself, this is not DFA, this is NFA. Why? Because when I read the input symbol 0, it reaches more than one state, that is Q naught Q1. So what is my concept now? DFA, deterministic finite automata. So this is not the right place to keep 0 in Q naught state. So apart from where I want to make self flow for this 0, so instead of Q naught, you can put Q1. Okay, so you can erase this one, right? So this is my DFA. So 0, 0, 1 is accepted now. What is for the string 0, 1, 0, 1? So 0, 1, 0 in the sense, so 0, 0, 1. Okay, now what is the string 0, 1, 0, 1? How it is possible? See 0, 1. I can make from Q2 to Q1, I can put 0 here. So now 0, 1, 0, 1, it is accepted, right? So you can take whatever may be the string. So here I just mentioned, right? So 1, 0, 0, 1, 101. Whether this string is accepted for this automata, let us check. So first input symbol is 1. So here I just put it as a 1. Okay, so 1, 0, again one more 0, again one more 0, 1, 0, 1. Now this string is also accepted. I hope everyone understand about this self loop, right? So in my previous lecture, I told about the clean closure of property. So it means 0 or more times, right? So first time 0, 1 is accepted. Without reading the input symbol 1 as well as 0, 0, 1 is accepted. In case I want to read 1, 0, 1, that time I read the input symbol 1 is followed by 0 followed by 1 is accepted. So that's why we call it as this self loop, we call it as a clean closure property, that is 0 or more times. Okay, so this is the way we are going to be constructing the DFA. And again, here they may put one more one, right? What is the possible string here? Just say 1, 0, again 0, again 1, here 1, right? 1, 0, 1. So this is also possible. So end with 0, 1, right? So these are the possible strings generated for this problem. So I can generate more number of ones, more number of zeros at end with 0, 1. So for that, we want to construct DFA like this manner. I hope everyone understand. Now let us see one more example. See, I want to construct the DFA for accepting set of all strings with 3 consecutive zeros. So what is the meaning here? Whenever 0 occurs, it should be 3 zeros, but the string can start or end with any number of ones. Okay, so whenever you people are going to be whenever you people are going to be end with a single 0, surely must pass 3 zeros. So this is the first input string. Okay, so now tell me how many states required for constructing DFA for this particular problem? First of all, we want to calculate the length of the substring. So here the substring is 000. What is the length of this string? 3. Additionally, you have to add 1. So total 4. So let us draw the diagram here. Q0, Q1, Q2, Q3. So after mentioning the states, next step you have to mention the start state as well as accepting state. This is my start state. Q3 is my accepting state. Right. The first string is 000. Now, the first string of the given question 000 is accepted. Then, according to this question, what are the string generate? What are the string is possible to generate? First string is 000. It is right one. Again, 1 000 is also possible. Again, 000 1 000. This is also possible. Or 000 1. This is also possible. So like this, your strings going to be generated. The condition is whenever 0 occurs, continuously 3 zeros appear. Here the single 0 followed by 2 0. Here single 0 followed by 2 0. Here single 0 followed by 2 0. So this is called consecutive zeros. Right? So now the first three zeros accepted. Now second one, I want to accept 1 000. So 1 000 string accepted for this, whether the 1 000 accepted for this automata? No. So now I want to include the input symbol 1. Where I want to include, can I put self loop? Yeah. If I suppose I put 1 here, there is no problem. Okay. So 1 000 now accepted. Okay. Now next string is 1 000 1. This is also possible, right? So first input symbol is 1 and end is 1. So in between three consecutive zeros appear. There is no issue. So where I want to put again 1, here I can put 1, right? So three consecutive zeros, right? So what about this one? 0 0 0 1 0 0 0 1 0 0, right? So can I put here from Q3 to Q1? Is it possible? See 0 0 0 1 0 0 0. It is right one. So this thing is also accepted, right? So first of, first of all, you have to think about in our question whether the substring is available or not. If it is substrings available, you have to calculate the length. In addition to that, add 1. For that value, you have to make state for the DFA. Afterwards, think about what are the strings accepted for the given condition, given question. So you can take 5 to 10 strings. So in single automata, that our entire string must be accepted. Okay, so that is the case in our DFA. So in this case, you can, according to the formal definition of my DFA, what is a capital Q in this diagram? What is a capital Q? So formal definition of capital Q. So capital Q, totally 4 states, right? From Q0 to Q3. So this is your finite set of states. Then what is alphabet? What is the input symbol here? 0 1. So 0 comma 1 is my alphabet. And which one is the start state? Q naught is my start state. So in this diagram, Q naught is my start state. What is the final state? Here only one final state, that is Q3. F is Q3. And importantly, we are not mentioning the transition, right? So transition, that is, if I suppose to read input symbol single, it will be reaches from one state to the another state. That is important, whether that particular information achieved by this automata or not, let us we discuss. Okay, so how we are going to be consider the transition here? See, transition of Q naught comma 0, where it will, where it is reaches from Q naught state, read the input symbol 0, it will be reaches Q1. Then transition of Q naught comma 1, from Q naught I read the input symbol 1, it reaches only Q naught. Next you have to consider Q1 state. Transition of Q1 comma 0, transition of Q1 comma 0, where it is reaches Q1 comma 0, it reaches Q2. Rest of the things you please work out. So definitely you will reach only one state here. So that is the our definition of my deterministic finite automata. In case here more than one state appear in the sense, that is not DFA, that is for NFA. Please make sure you please make clearly. Whenever I read the input symbol 1, whenever I read the input symbol single, it will be reaches only one state, not more than one state. That is our definition of my deterministic finite automata. Right? So next problem is, so I hope everyone understand about the about two problems, right? So next one we will see, I want to construct the DFA that accepts all the strings over an alphabet 0, 1, accepting all strings with a substring 0, 1. So here, you please understand the question. The substring is 0, 1. Here, they may not able to mention whether the substring started or ended. They may not able to mention whether the string must be started with 0, 1 or else the string must be ended with 0, 1. It should be substring 0, 1. So it means, see, 0, 1 is my substring. After this one, you can make whatever may be the symbol, that is combination of zeros and ones. And before 0, you can make combination of zeros and ones. Okay. So this is the condition. Now tell me how many states are required for this automata. Totally 3. Why? Because my substring is 2. What is the length of the substring? 2. And also you have to add one more one. So totally 3. Right? So in this particular example, I need 3 states. Why? Because my substring is 0, 1. I want to calculate the length of the substring, that is 2. Then you have to add 1 along with my length of my substring. So total value is 3. So According to this problem, I need only three states to solve. Q0, Q1, Q2. Right. So this is my start state. Q2 is my accepting state. So 0, 1 is my first string, okay? So 0, 1 is accepted, right? Suppose 1 not 1, this is also valid string, right? Where I want to put this one? Shall I put over here? Yeah. So now 101 is accepted, right? Then any other string, for example, 1001. So this is substring, right? So we 10, okay. What about the 0? Shall I put here? I think it is not violating the DFA rules, right? So 1001, it is accepted, right? What about 10101? This is also valid, right? 10101. So 101. Can I put 0 here from Q2 to Q1? If I supposed to put 0 here, now this string is accepted. See, 1, this 1, 1, 0, 1, 0, 1. So see, from Q0, 0, Q1, this one is Q2. From Q2 it reaches Q1. From Q1 it reaches Q2, right? So this string is also valid one. So this 10101 is also accepted for my automata, right? So now you can generate the string for this particular problem, that particular string accepted for this automata, right? You just make for example 0 1 1 1 0 1 1. Whether this string is accepted for this automata, let us see. 0 1. See, again I need one more one, right? So 0 1 1, right? So in this case 0 1 is my substring, right? Exactly. So 0, I read Q0 from, sorry, from Q0 to Q1, I read the input symbol 0. Again 1. So what about one more one? Can I put over here? If I supposed to put here 1, double 1, right? 0 1 1 1. Now this string is also accepted, right? So this is the way you are going to be construct the DFA, right? I hope everyone understand about how to construct the DFA. Let me see one more small example. Right. Here I just draw the, I want to draw the DFA over an alphabet A comma B with the prefix AB. So it's very simple. Starting prefix is Z. Starting prefix is AB. So what is the idea to construct the DFA for this problem? First of all, you have to calculate the length of the substring. The substring is AB. So the length of the substring AB is 2. So 2 plus 1, 3. So totally I need 3 states of this automata. So Q naught, Q1 and Q2. Just make it acceptance state Q2. This is my start state. Right? So what is the condition? Your starting prefix is AB. So the meaning is the first input string is AB. Then starting string is AB. Then followed by a combination of A and B's. You can put many number of A's and many number of B's. Okay. So for that you can make self row A comma B. That's it. Now in this case, A B is also accepted, A double B is accepted, A B A is also accepted, and A B A B B A. These are all the strings accepted for this automata. Okay, so remember in the self loops nothing but the clean closure property takes place. That is 0 or more times. So here please listen, here the input symbol is vary. I have not put same input symbol. Okay, whenever I read the input symbol A from Q2, it reaches only Q2. The transition of Q2 comma B, it reaches only Q2, not more than one state. Okay, so this is called, this is the way we are going to be constructing the deterministic finite automata. This is the way we are going to be approaching the problem, right? So in next session, we will see how to construct the NFA and how we are going to be converting the NFA to DFA using subset construction. Thank you.